So now we'll go for the second experiment from this setup. So you can use this Wien bridge as one of the oscillator. As we know, the main purpose of oscillator is to generate either sinusoidal or cosine waveform, okay, with the required frequency. So let us check this Wien bridge as oscillator, whether it is generating sinusoidal waveform or not. Okay, so for that we are going to use this second circuit in this kit. Okay, so here this Wien bridge oscillator, you can use the transistors or you can use op amp. Okay, as you know, op amp is nothing but operational amplifier. It is internally is having some transistorized circuit. Okay, so it is having so many advantages. That's why here we are going to use Wien bridge oscillator using op amp. Okay, for this op amp, first of all you need to apply plus or minus 12 volts. So now I am applying this plus 12 volts to the positive terminal, plus 12 volts, and next minus 12 volts to the minus 12, and next ground. Okay, so these are the terminals of the op amp. Okay, these are the supply terminals. Okay, and this plus and minus are non-inverting and inverting terminals. Okay, those are connected to the bridge elements. Now, so here first of all in this table we are going to set R4 and R8 value as 10 kilo ohms. Okay, now let us connect that. So here I am selecting this R4, which is connecting in the one of the bridge arm, and this is 14 is connected to here. So this R4 value, it is internally how much? 10 kilo ohms. Okay, and next we are going to connect this R8 between 9 and 10. Okay, nothing but we are connecting some Wien bridge. Okay, so if you see here, the resistance is connected in parallel, and here the combination is series combination, resistance and capacitance. Okay, so this R8 value also, it is internally 10 kilo ohms. Okay, both R4 and R8 values are 10 kilo ohms. Now we need to observe the waveform generated by this Wien bridge oscillator, and also here one more connection you need to do. You need to short this 11 and 12. Okay, so this is over. Now connect this output terminal to the CRO, because this oscillator is going to generate sinusoidal waveform, which you need to which you can observe using CRO. So I am connecting positive terminal here, CRO positive terminal, and CRO negative terminal is connecting to the ground. Okay, so this is the Wien bridge oscillator setup. Now we'll switch on the circuit and keep this VR3 initially at extreme left position, that means minimum position. Now switch on the power supply. Okay, so now I will keep on changing this VR3 resistance value of this part, which will internally adjust the frequency of the sinusoidal waveform generated by oscillator. Okay, so for this, when you are rotating this knob, you need to check the waveform in CRO. Okay, now see the CRO. Okay, so now I am changing this knob VR3. After some value of resistance, you are going to observe the waveform, sinusoidal waveform in the CRO. Okay, so now this Wien bridge oscillator is generating sinusoidal waveform perfectly. So you can click on this run stop button, then you can clearly observe that sinusoidal waveform, and here you need to observe the frequency. So how much it is? 1.53 kilohertz. Okay, so the generated frequency is 1.53 kilohertz. That is practical one. Now let us compare this frequency with theoretical calculated frequency. Okay, so for the Wien bridge oscillator, as you know, for Wien bridge the frequency is formula it is 1 by 2 pi root square root of R1 R2 C1 C3 C4. Okay, so here one of the resistance is R78 because that is connected between this 7 and 8 terminals, that is R4 whose value is as I told you, this R78 is nothing but R4 whose value it is internally 10 kilo ohms, and similarly the second resistance R910, that means between 9 and terminals we have connected the resistance whose value it is also 10 kilo ohms, and the capacitance are fixed capacitances, those are 10 nanofarads. Okay, so by substituting these values in this formula, then you will get some frequency. Okay, if you compare this frequency and generated frequency, both are almost same. Okay, so if we calculate this theoretical frequency, it is around 1591, that means 1.591 kilohertz. Okay, so this is theoretical frequency and this is calculated or generated frequency from the experiment. Okay, both are almost same. So by varying this you can conduct this experiment for different values of resistances, 20 kilo ohms, 39 kilo ohms, 100 kilo ohms. So by varying this resistance, your frequency of the sinusoidal generated waveform will be changed. Okay, that is the main advantage of this Wien bridge oscillator.